You're here because you want to master empirical formula and molecular formulas with a University of Cambridge graduate. This is actually part 4 of our More Concept lecture series. If you want to watch our previous lectures or you want to watch the follow-up lectures after this one, be sure to check our playlist or check out the link in the description below so that you can watch more videos. Hi, I'm Brendan, and I've been helping students like you achieve their mastery over chemistry over the past 8 years, and I hope that you can learn something from me today. Before we begin, be sure to go into the link below so that you can download a free copy of my notes and use it to follow through our lesson today. Okay, so now let's move on to something that is probably new to you, empirical formulas. Empirical formula is just the simplest ratio of elements in a compound. Okay, and as compared to molecular formulas are like the actual ratio of the elements in a compound. So in order to calculate the empirical formula, right, of a particular compound, you will need to use the information from the question. Okay, usually it involves like getting the mass or the percentages of each element inside a compound, right? And through this specific method that you have to learn, right, you can easily find the empirical formula. All right, so this is a method that involves you drawing a table. I repeat again, you must draw the table. It is very important. Okay, you not drawing the table will lose you marks. So how do I do this? Let's say a compound consists of 7 grams of nitrogen, okay, combined with 4 grams of oxygen, and you want to find the empirical formula, right? You must draw the table. So the first row of the table is usually elements or molecules. They gave nitrogen and oxygen, so it's just elements, okay, and it's just N and O over here. Then you want to put down mass. They give you mass in grams, so you just put down the mass, right? For now, we're just quoting the values, 7.0 and 4.0. Then you want to find the number of moles. Okay, remember what we learned just now? If we have the mass and we divide it by the molar mass or the atomic mass, we can get the number of moles of the particular element. So to get this, we will take the 7.0 mass that we're given divided by the relative atomic mass of the nitrogen, which is 14. Okay, if you do that, you will get 0.5. Again, I must say it's important to write your calculations inside the table as well. And then for oxygen, this is 4.0 divided by 16, which gives you 0.25. Right? Once you've done that, you can calculate the simplest ratio. So how we usually do this is we're going to divide it by the smallest number. Okay, the smallest number of moles that we have. So in this case, the smallest number is 0.25 moles. So we take 0.5 divided by 0.25, and this will give you 2 over here. And this one will give you a 1. Right? So the simplest ratio, okay, once you've done this, please draw your lines in the table. Oops. So the simplest ratio over here, okay, which is in other words the empirical formula, do write your concluding statement. Okay, this is just N to O. So that is the empirical formula of this compound. Okay, let's take a look at another example. So here we have 12.0 grams of anhydrous magnesium sulfate, and then combines with 12.6 grams of water to form hydrated magnesium, and they ask you to find the formula of the hydrated magnesium sulfate. And here I did give the answer already, right? But it's about how you arrive at this answer over here. So again, we're going to draw a table. In this case, we're given the element and molecule as well, right? So you realize that you are given 12.0 grams of magnesium sulfate and 12.6 grams of water. If you're given data like this, just treat it as such, right? So here we have MgSO4, right, which is the formula of anhydrous magnesium sulfate, and then you have water. Okay, then you want to put the mass down in grams. So this is just 12.0, and then this is 12.6. Next, you want to find the number of moles. Right, so now you're divided by the MR. So 12.0 divided by the MR, which is 24 for magnesium, 32 for sulfur, and then 16 times 4 for magnesium, for the oxygen. And this will give you a value of 0.1. Okay, for water, it's 12.6 divided by 2 times 1 plus 16. This will give you a value of 0.7. Okay, and with that, we can find the simplest ratio. So again, the smallest value or number is 0.1. So we divide everything by 0.1. 0.1 divided by 0.1 is 1. 0.7 divided by 0.1 is 7. Okay, and draw your lines. Okay, so from here we can conclude that the empirical formula for this whole molecule is MgSO4 7H2O. There we go. Okay, let's take a look at another example, right? So a compound has the composition by mass of 29.4% calcium into 3.5% sulfur and 47.1% oxygen. So find the empirical formula, right? So how do I do this, right? All you have to do, now that you're given percentages, you just do it the same way, right? You draw the table and you treat the masses as these are percentages. So here we have element or molecule, right? Here you're given calcium, sulfur, and oxygen, right? And then you are given the percentage by mass. So here I like to just put mass per 100 grams. Okay, you can put mass / grams as well, that works as well, right? So this is just 29.4, 3.5, and then 47.1. And then next you want to find the number of moles. So you just take each of these values divided by the AR, right? And you will get specific values over here. Okay, if you just calculate it properly. Okay. Right, so once you've done that, right, you can find the simplest ratio. Right, so again, find the lowest number. Lowest number is 0.734. Okay, if you get something like this, you can actually estimate it to be about equal, right? Again, you can always round it up or round it down, right? Usually if it's like 1.0 something, like 1.05, 1.06, okay, or 0.95, right? You can always round it up to like a 1, for example. Okay, but you don't round it for everything, right? Only if the value is close enough to like a whole number, right? And then, of course, this is going to be, okay, 1 and then 2.94 divided by this. Okay, it's actually going to give like a 4. So from here, you can draw your lines. So just draw the lines. I must say it's important to draw the lines because I did minus marks from this before when I was schooling. So from here, you will know the empirical formula is CaSO4. Okay, so that's how you get your empirical formula. Alright, so let's move on. So now that we know how to calculate our empirical formula, it's time we learn how to calculate our molecular formula. So remember, your empirical formula shows the simplest ratio between the atoms in a compound. But your molecular formula actually shows the actual ratio, the exact number of atoms of each element in a compound, right? So if the empirical formula is like AXBY, then the molecular formula, you should always treat it as like AXBY whole thing times N, okay, where N is a value which is like 1, 2, or 3, right? So basically, to find the actual exact number of atoms, right, you can take the empirical formula and then you times a certain value, right? And to find this N value over here, usually you will take the relative molecular mass, okay, divided by the relative mass from the empirical formula. Okay, so let's take a look at an example over here and learn how we can actually present our answer. So here they say the empirical formula of a compound is COH3. So its relative molecular mass is 62. So find the relative molecular formula. So here, the first statement we always want to write is that we want to let the molecular formula be COH3, which is the empirical formula, the whole thing with N over here, right? And then we want to present this such that MR of COH3N, okay, this is equals to 62, right? And this is equals to, right, if you were to calculate properly, this is actually 12 plus 16 plus 3 times 1, which is the relative mass of the empirical formula, whole thing times N. So here you can actually find out that N is equal to 62 divided by this relative mass over here of the empirical formula. You realize that N equals to 2. So if N equals to 2, right, then we know the molecular formula is just the empirical formula and all the atoms times 2. So the molecular formula is actually just C2O2H6 because all the atoms you just multiply by 2. Alright, so this is how you present your answer as well. I must emphasize the presentation for this kind of question is very, very important. It's very easy to lose marks, like method marks, for not presenting it properly. If you enjoyed today's video, Do remember to click the subscribe button so that you can enjoy more free content from us and improve your chemistry with us together. If you want to join my community of students to learn more secret formulas to acing chemistry, do check us out in the link below and sign up for a free trial class today.